Okay, so this is your review for tomorrow's quiz. On the quiz tomorrow, you will be given a question where you're asked to graph the angle and then find one positive and one negative coterminal angle. So the graphing portion is going to be on your answer sheet. You're going to have a little cross that looks like this. And we're going to go ahead and graph the positive 147 degree angle. Remember, when you graph a positive angle, you go counterclockwise. So I'm going to go 90 degrees, and then I need to go a little bit more, another 57 degrees to get it to 147. Make sure you include the arrow so I know you went in the correct direction. This is how you would graph the 147 degree angle. Now, as far as the positive and the negative coterminal angles, technically there's an infinite number. You could keep adding and subtracting 360 to get a whole bunch. If you want Canvas to grade it, just give me the very first one you would have gotten by taking 147 and adding 360. And the first positive coterminal angle you would find would be 507 degrees. If you add 360 again to get another positive coterminal angle, Canvas would mark this one wrong, and I would have to go back and hand grade it. So if you're hoping to see a score, just put in the first positive you encounter. For the negative coterminal angle, we need to subtract 360. So this is super easy stuff. You are going to be given a calculator on lockdown. That will be the calculator you must use. You cannot use your scientific or graphing calculator, just the basic one that's provided on lockdown. So the positive coterminal angle would be 507 and the negative would be 213. So as long as you understand what to do, this is a super easy question, and you have a calculator to do the adding and the subtracting of 360 for you. Let's try the next one. Here we're going to be graphing a negative angle. This time we go clockwise. So I'm going to go 90 degrees, then I go another 180, and now I need to go another 45 degrees to make it to the 225. Again, include the arrow so I know that you went in the correct direction. This would be the negative 225 degree angle. You're only graphing one angle, the original one that's given to you. You do not have to graph the coterminal angles. Now, to find a positive coterminal angle, I will take the 225, the negative, and add 360 degrees. Once I add 225, negative 225 plus 360, I get positive 135 degrees. To find a negative coterminal angle, I'm going to subtract 360. And this will give me negative 585. And you will enter both of those. Pretty good on that part. This was from 5-1. Now we're going to convert between a decimal degree to degrees, minutes, and seconds, and vice versa, degrees, minutes, and seconds to a decimal degree. This is where you can use your calculator for the multiplying and dividing by the 60 and the 3,600. So for the first one, this is a decimal degree. We are going to convert it into degrees, minutes, and seconds. So the degrees stay the same. They're the whole number portion. So I can see that 56 degrees, and they're going to have a little box. And it's going to say, it'll have this, and it'll have a little degree symbol. So in there, you're going to type the 56. Then it's going to have another box that's going to let you write the minutes in it. And then it'll have another box where you're going to write the seconds in it. So to get the minutes, we take the decimal portion here, 0.945, and we're going to multiply that by 60. Once I multiply this by 60, I get 56.7. I'm going to take the 56, it goes in here, and that becomes my minutes. Then I take the decimal portion, multiply this by 60, and then my seconds are 42. So the degree symbol, the minute symbol, and the second symbol is already there. You're just typing in the number. Then when we go the other way, from degrees, minutes, and seconds to a decimal degree, we're dividing by 60,600. So the minutes get divided by 60, and the seconds get divided by 3,600. So what you can do is the 149, those are going to be your degrees. I'm going to put the decimal point, and then what I need to do here is divide this, get this answer from my decimal, becomes 0.56 repeating, and then I'm going to add that to 56 divided by 3,600, and this gives me, let's see, 0.0155 repeating. So then I'm going to add those two, and then that becomes my decimal. So my decimal becomes 582 repeating. I'm going to round it to 3 decimal places. So the final answer, 149.582. It does. It says the 3 places. The 6 is the adjacent, and then I don't know the hypotenuse. Now, you might also get your question phrased in this format. They might just give you a triangle here. You might have a little theta here with no capital letters. And then over here, they'll have a little a and a little b. And then they're going to say a equals 5, b equals 6. And it's going to say, find the 6 trig functions for angle theta. It's the same setup. You're still going to identify these sides. You could put a 5 here now for A. The 6, the 5 is still opposite of theta. The 6 is adjacent. And we still need to find the hypotenuse. So just be aware, it might say find the 6 for angle A, or it might say find the 6 for angle theta. So now let's find that hypotenuse. We need to do Pythagorean theorem. A squared plus b squared equals c squared. A squared is 5, or A is 5. B is 6. I don't know c. So 25 plus 36 gives me 61. Square root it, and my hypotenuse is the square root of 61. If you could simplify this radical, you will, but we can't. So we're going to leave it the square root of 61. Now that I have all 3 sides and I've identified which one is opposite, adjacent, and hypotenuse, now I can put them into the trig functions. So over here, we're going to do sine of A, or it could be sine of theta, depending on your quiz. And sine is opposite over hypotenuse, which is going to be 5 over the square root of 61. I need to rationalize. If you don't rationalize tomorrow, you get it wrong. So I need to multiply this by root 61. 5 square root 61 over 61. This is the sine of angle A. Now let me show you how you're going to type it into Canvas, because it's a square root. For this answer here, we're going to be typing 5, the letters S, Q, R, T, parentheses 61, slash 61. It tells you in the question how to format it. Now, if you think you're going to get confused for this type of question where you're typing in a square root, if you want to just put see my work, that's fine. But it's just simple enough. Instead of putting this, you're typing the word SQRT in front of the number that should be under the radical. It's that easy. For fractions, you're using the slash. So now we need to finish this question. All we found is 1 and we need 6. So now let me find the reciprocal to sine, which is cosecant. I flip it. square root of 61 over 5. And I leave it because the radical can be in the top. For cosine, this one's adjacent over hypotenuse, or if you're memorizing it as x over r, you can do that way as well. So my adjacent is 6. My hypotenuse is still 61. I need to rationalize again. This simplifies into 6 times square root 61 over 61. The reciprocal is secant. Flip it. So square root 61 over 6. Tangent, TOA, opposite over adjacent. My opposite is 5. My adjacent is 6. Cotangent, flip it. 6 over 5. And those are your 6 functions. So again, you're going to show me the work for finding that hypotenuse and then put them into the functions, rationalize when necessary. Let's try the next 2. This time, instead of it already drawn as a triangle for you, they're giving it to us as an ordered pair. So if it helps you to graph it, you can. You really don't need to. So just remember, in your ordered pair, the first number is x, second number is y. Remember to find r. We're using the formula x squared plus y squared, and then square root it. R is equal to -4 squared plus 3 squared, 16 plus 9, 25, and the square root of 25 is 5. So x is equal to -4, y is equal to 3, and r is equal to 5. If you wanted to graph this order pair, 1, 2, 3, 4, 1, 2, 3, here is the triangle it creates. This is the hypotenuse. It's the distance from 0, 0 to that order pair, and it's 5. And then you'll make the triangle back to the x-axis. This side length here is -4, and this one's 3. If you recognize that this was a 3, 4, 5 common Pythagorean triple, you could have saved the work for the finding r. All right, so now that I have x, y, and r, now I can plug them in. Now, if you would prefer to do SOHCAHTOA, this is opposite, opposite, this is adjacent, and this is r, this is also x, this is y. So let's plug it in. So for this one, sine of theta is equal to opposite over hypotenuse, 3 over 5. The reciprocal, cosecant, flip it, 5 over 3. Cosine is adjacent over hypotenuse. Secant, it's its reciprocal. Tangent, TOA, opposite over adjacent. And cotangent, flip it to its reciprocal. And there's your 6 trig functions. The next one. This is, notice there's a 0 in the ordered pair. This is going to come from one of my quadrant angles. It's actually going to be a 90-degree angle. Let's go ahead and just give ourselves a sketch here. So is the ordered pair 0, 6. Now, if you want to use the ordered pair the way it's given, you can. Remember when I taught this lesson, I also told you that you could use the ordered pair, the first one you encountered, the 0, 1. So let me do it the way it's given, and then I can also show you using the ordered pair 0, 1. So remember that the r value is the length of this radius, or the length of that segment. If you need to see the thing worked out, you can. So r is equal to 0 squared plus 6 squared. 0 plus 36, square root it, and r equals 6. So if you're going to use the original order pair, x is 0, y is 6, r is 6. So let's plug them in. So sine of theta is equal to y over r. So 6 over 6 simplifies to 1. Its reciprocal, cosecant, r over y, 6 over 6, still a 1. Cosine, x over r. My x is 0, my r is 6, simplifies to 0. Reciprocal, r over x, 6 over 0. Undefined, type in UD, lowercase. Okay, so you need to know the difference. When there's a 0 in the numerator, you're going to type in a 0. When there's a 0 in the denominator, you're going to type in the letters UD. Know the difference. Yes?
When we do a problem like that, do we need to graph?
No, you don't have to graph it. Okay, tangent is y over x. So for tangent, 6 over 0 simplifies to 0. Simplifies to undefined. And then cotangent, x over y. And here x is 0, y is 6, simplifies to 0. So again, when the 0's in the denominator, you're going to type in UD. When 0's in the top, it simplifies to 0. Now, when I taught this in the notes, we could have also done this same problem using the first order pair that is on this angle, which was the 0, 1. So if you prefer to use x equals 0, y equals 1, and r equals 1, you can do it and you will get the exact same answers. The only difference, for example, when you do sine, you're doing y over r, 1 over 1, which is 1. So you don't have to simplify it. Either way, you get the same answer. Just remember, when you use those 4 initial points, the r value is always 1. Everybody good there? All right, let's try the identities. Now, let me show you what I saw when I was looking at some of the submissions. So, for example, on number 8, or number 9, let's just do 9. Some students realized that tangent was y over x. So they just said, okay, y equals 4, x equals 3. And then they found r. If you do this, you will get it wrong. Okay? Notice the instructions say to use the Pythagorean identities. I want to see that you can demonstrate on how to use these identities. You're going to be using identities next year in pre-calculus and in calculus. There are 3 Pythagorean identities. Now, you may also need to use the reciprocal identities on the quiz. The 3 Pythagorean identities, and remember, you can manipulate them in any way. So the first one is sine squared theta plus cosine squared theta equals 1. The next one is tan squared theta plus 1 equals secant squared theta. And then 1 plus cotangent squared theta equals cosecant squared theta. These are the 3 Pythagorean identities. Then you also have all the reciprocal. So for this first question, and to figure out which one you're going to use, look at what's given. I'm given secant, and I'm trying to get to tangent. So luckily for me, I can come up here, and the second one has both of these in it. So now all I need to do is I'm going to go ahead and write it underneath. tan squared theta plus 1 equals secant squared theta. I'm going to replace the given right here, and I'm going to square it. So tan squared theta plus 1 equals negative 9 over 4 squared. I now need to square that 9 over 4, becomes 81 over 16. I now need to move the 1 to the other side. So now let me finish the problem up here. So now I have tan squared theta equals 81 over 16, and I'm going to change the whole number 1 and make it 16 over 16. So now tan squared theta is equal to 65 over 16. The problem did not ask for tan squared, it just wants tan. So I need to square root both sides, and tangent of theta is equal to the 65 under the square root. I can square root the 16 and make it 4. Now, when you solve for a square, a variable squared, remember you get both plus minus. This is where I need to go back and see which quadrant my answer is located in. My answer is supposed to be in quadrant 2. So this is where I'm going to do my all students take calculus. And I can see that in quadrant 2, the only thing that's positive here is sine and cosecant. The other 4 are negative. So from this answer, I'm only keeping tangent of theta equals negative square root 65 over 4. If you're keying this into Canvas, you're going to key in negative SQRT 65/4. But again, the answer is really all the work. It's set up as an essay question. If you don't want to have to type all this in, you can just type in "see my work," and I will look at your work paper to look for all of this. No work, you lose the points. Even if you have this correct answer, but you did not use identities, it's wrong. Let's try one more using identities here. This time they want us to find cosecant, and they're giving us tangent. So for this one, I'm going to use the identity 1 plus cotangent squared theta equals cosecant squared theta, because I'm going to use a reciprocal identity first. I'm going to change tangent into its reciprocal, and I'm going to make this cotangent, and I'm going to flip it. Now I can replace this with the 3/4. So 1 plus, yes.
I'm trying to join from another device because my iPad isn't working right now.
Okay.
Oh, okay. Thank you.
Got you in. Thank you. All right, everybody good so far? So now I'm going to replace cotangent squared with 3/4 squared. I need to square that 3/4, and I get 9/16. I now need to combine my like terms over here. So I'm going to change the whole number 1 and make it 16 over 16. So I can add it. I need a common denominator. And I get 25 over 16 is equal to cosecant squared theta. I need to square root both sides. This gives me plus and minus 5 over 4 is equal to cosecant theta. Here's where I use my all students take calculus. The question told me to find a theta in quadrant 3. Remember, in quadrant 3, it's tangent and cotangent. These are the positive ones in quadrant 3. So the only thing I'm keeping here is negative. So cosecant theta in quadrant 3 is negative 5/4. So again, you must use the identities for this question. You could use it by, if you want to double check it, by just turning tangent into y/x and then find your r value, and then from there you could figure it out. But again, you must use the identities. Any questions? Anybody need me to go back to anything?